Hello everyone, NodLabs here. Today we're going to be making this very simple slingshot in the Godot Game Engine, version 3.2.2 stable, and let's get right into it. Before I begin, I want to give a first principles approach on how you would go about making a slingshot by yourself, and I'm just going to be going over the thought process I had. So essentially what you want, or what anyone wants when they make a slingshot, is they want to be able to grab a point in the frame. So of course now we're going to need a frame. Want to grab a point anywhere. Once you grab the point, we want to be able to drag to any point elsewhere, and we can see the line. So of course we're going to be using a line 2D. So once we drag it, we can get this point as well. We want to find the difference, and we want to be able to set that as our linear velocity or something. We want to be able to see our results. So if we draw a line like this, our player should, let's say it's a kinematic body 2D, rigid body 2D, whatever, it should be able to move about the same length. And if the line is like this, then our player should move to a point about this far. So that's essentially what we're going to be doing. Of course, we want to make sure that we can instance this scene and we can use it many times. So that's also one thing we want to keep in mind. So if we're going to be using linear velocity, it will be a good idea to use a rigid body. Of course, you can extend if you modify this a bit, modify the project's code, obviously. You could make it work to a kinematic body 2D, even an area 2D if you wanted to. But I'm going to be using rigid body 2D just for simplicity's sake. And of course, we're going to be using a line 2D. So let's get right into coding this. So here I just have a very simple scene setup with a game, just a regular Node 2D to house the game scene. No assets, so you can make this right where you are right now. You don't have to download anything. Let me just close this. So of course, we have our game scene, line 2D player. I'm going to be going over how I made these. So in the line 2D, you can see that we just have a line 2D, and I just attached a script that extends line 2D. If you're wondering how I attach the script, I went here to line 2D. I click this green button over here, and I just click load. Or for you, it would say create, because you haven't made it yet. But whatever. For the player, I said I went with the rigid body 2D. You can see here it says rigid body 2D. I attached the regular Godot sprite, which comes with every project, and a collision shape. Just made it a rectangle. Although we're not colliding with anything, so whatever. We just save these. And of course, I attached the script here as well because we need it. I think we should start with the line 2D because that will help with understanding how the line mechanism will work. Then we can implement the player's velocity. So with the line 2D, I went over here to the points and I made sure the size was 2. Because I said before, we're just going to be drawing from point A to point B. When there's no point C, point D, there's no point Z. We're just going to be making sure that the size is 2. So I'm just going to be starting off by declaring some variables we're going to be using. We want to make sure we get a declaration to our player because we want to make sure we can edit the player's values, for example, linear velocity or some direction variable. We also want to make sure we get a vector start and vector finish. And that's because if you saw in the picture, we want to make sure we get a starting point and a finishing point. So like I explained here, we want to make sure we get a starting point and we want to make sure the starting point doesn't move. So what's the best way to go about tackling this? If we're going to be using our input methods, we can say input action press. So this will just be, as soon as this is just pressed, then while it is pressed, this line can be drawn. And while we release it, or as it's just released, we can get this point. So based on that logic, we can say if input is just action press, click. And if you see over here, if I go to my project settings, input map, if I type in click, I already have it. And click is just a device button. It is just a mouse left button. So you can see that once we just press, we want to make sure the vector start is set to our global mouse position. And we just want to set the finished vector to our, we also want to set the vec finish to vec start because that just helps with any sort of artifacts being made. And I'll explain later what that means. So you can see right now nothing happens because we're not drawing any line. So we should draw the line now. So like I said before, we're just going to be doing if input is action press click. So now we're doing if the action is pressed. Before it was just pressed. And if I go over here to my paint, you can see that I was talking about how this point would be just pressed. This one will be just released. And this one over here in the middle, I'll do in red. Why not? Is going to be pressed. So you can see here it's pressed. And what this means is while we are holding down the mouse button, we're going to make sure that the finish vector is going to be equal to the global mouse position. And 0.0 is going to be equal to the start vector. 0.1 is going to be equal to the finish vector. I feel like I didn't explain this well, so I'm just going to explain it in a simpler way. Over here in the pool vector 2 array, you can see that size, it says 2. So we have 2 points here, 0 and 1. So 1 and 2. But of course, arrays start from 0. If they don't, In some programming languages, then that's just crazy, but whatever. So we just want to set the 0th point to where we started and the final point to where we finished. That should make sense. And in fact, I believe we can just move this up here and we will get the results we want. So you can see we can draw a line to where the mouse started, where the mouse is going to finish, and that's about it. But again, nothing's happening because we're not calculating anything so far. We're just telling the line how to position itself. Now we're going to be doing the final step. What happens when we release the mouse? So before I talked about having our action just pressed. This is going to be pressed. And now we're going to be working with the just released. So this is basically what we're going to be saying. So if the input is action just released, click. We're going to make sure that the player dir or direction is going to be equal to the vector start minus vector finish multiplied by 2. Yeah, that's all we're going to be doing. And if you want to, you can normalize the vector and multiply it by 100 if you want to have the slingshot always produce a consistent result. But in some cases, you don't want that to happen. And if we run the scene, you can see that we will be getting an error. Why? Because we have not set up anything in the player script. Now, what are we going to say in the player script? Well, because we have this error that there's no direction declared, we'll just declare a direction variable and say in the physics process function, we're just going to be making sure that our linear velocity is equal to direction. And if you're wondering, what is this direction? He keeps saying direction. What is he saying? Well, we're just setting the direction equal to the vector start minus vector finish. Now, if you don't want to see the vector math explanation, you can just skip ahead. I'll probably leave a timestamp somewhere here. Actually, I'm going to leave it right here. But yeah, so I'm just going to explain what that means. So let's say this white box is our scene. We have vector start over here and vector finish over here. Actually, I always do it in this position. So this is going to be the start vector and this is going to be the finish vector. Now, if you know something about Godot, Godot measures its lines or vectors from the corner, 0, 0. So it's just going to draw a line from here to here. And then it's going to say, okay, so that's vector start. Now we're going to go to vector finish. And if you know anything about subtracting vectors, oh my god, I did this too big. But if you know anything about subtracting vectors, we're going to take the first vector. Oops, let me just grab this guy. So I'm just making a copy of it. I'm going to move it to the side so we can see it without all this clutter. And of course, I always sometimes forget to mention that these vectors have directions. This vector is pointing in this direction. It's pointing towards the start point. And this finish vector is pointing towards the finish point. And now, if you see, and this copy is going to be pointing in this direction. However, when we subtract a vector, we're going to be making sure that the second vector, or the one that we're subtracting with, is going to be pointing in the opposite direction. So let's see if I can fit it. Ooh, it just doesn't fit. Give me 1 second. So sorry, I just had to make sure everything fits so you can see it. Now you can see that we have to flip the vector. We have to make it point in the opposite direction. So before, this one pointed down here, not up here. Now it's going to be pointing up here. Oops, wrong tool. Now it's going to be pointing up here. And of course, the orange vector is still going to be pointing in this direction. Now, how do we subtract the vector, or what does the product, or not product, I should say, what does the resultant look like? Well, it's just going to be following these paths. So I'm going to be the dir, the player.dir. So it's just going to follow this path, and it's going to say, oh, this is the next point in the path, and now I'm going to go over here, and this is our resultant. And that's essentially what we do when we subtract vectors. We just take the first vector and line it from head to tail. So this is head of the first, tail to the second, and then we just keep doing that until we get the final product. And I'm going to go on a little bit of a tangent here. If you want to subtract another vector or add a vector, you would just put another vector down. Actually, I shouldn't do that color, but you just put another vector down, and there you go. That's your next vector. If you're adding it, you would just keep the same direction. You saw I drew it in this direction upwards, so I'm going to keep it. And then if we're going to be getting the resultant, I'll do the resultant in red again. So we're just going to be like this, and then we're going to say, oh, there's another point. So we're going to be like that. We're going to be over here, and that's the other resultant. If we run the scene now, we're going to see the fact that our player moves, and it's going to be moving forever. Why? Because we never said that the direction should go back to a stopping point or a value of 0 after a bit. So now you can see. Now the direction we point this slingshot in is going to help our Godot player move in that direction. Now, of course, we can multiply this by 2, which will just increase the length, make it go a bit faster, right? We can also get rid of this, we can also do dot normalize multiply by 100. So we can also do this, dot normalized multiply by 100. So no matter how long this line is, we always get the same result. And of course, to make that more apparent, you can just say dot multiply 1000. So this really small amount goes that far, but this really large amount, and by the way, I'm still editing it, goes that amount, it's the same. So you can do whatever you want with this. And in fact, I just like to multiply it by 2. So yeah, that's all I have to say for this tutorial. There are extensions. You can make this line you can make the line change colors with its size. You can make the Godot sprite move in a little bit of a more creative way, but that's all up to you. And that's all I have to say for this tutorial. Have an amazing day. And just to satisfy my desire to become a 3D game maker, I'm going to make this a little bit of a triangular prism. But that's enough for 3D vector math. Not 3D vector math, just vector math, and we're going to go back into the game scene. And now comes the final step. Once we have our action just pressed, our action, so not line 2P, line 2D.